Hello, and welcome. Take a moment and just listen. What do you hear? Maybe it's the hum of your computer, the sound of traffic outside, or perhaps just the quiet rhythm of your own breathing. Now, look around. You see the light filling your room, the colors of the objects around you. Have you ever stopped to think about what all of these things, sound, light, electricity, even the waves in the ocean, have in common? It might seem like they are completely different worlds. But deep down, at their very core, they all share a secret language. A fundamental rhythm. Today, we're going to learn that language. We're going to decode the single most important building block of the physical world as we know it. And it all starts with this simple picture. This, right here, is our key. It might look like a simple drawing from a high school textbook, but I promise you, by the end of our journey today, you will see this image as a blueprint for the universe. We're going to explore the concept of a cycle. Let's start by deconstructing what we're looking at. Think of this as a story being told over time. This flat, horizontal line is our timeline. The further we move to the right, the more time has passed. Simple enough. It's the one of our story. This vertical line represents, well, it could represent almost anything that changes. It's the what of our story. For a sound wave, this axis could be air pressure. For an electrical signal, it could be voltage. For a wave on a pond, it could be the height of the water. The line in the middle, labeled with a 0, is what we call the equilibrium or rest position. This is the state of things when there's no wave, no disturbance. It's the perfectly calm, flat surface of a lake before a stone is thrown in. And this beautiful, flowing, up and down curve? This is the wave itself. This is the story of the disturbance. It shows how our what is changing over when. Now, let's get to the star of our show, the cycle. The definition says a cycle is one complete repetition of the wave pattern. Let's break that down with a powerful analogy. Imagine you're on a swing set. You start at the bottom, at rest. That's our 0 point. Your friend gives you a push. You swing upwards and forwards, reaching your highest point. In our diagram, that's this first beautiful arch, the peak of the wave. We have a special name for this peak, the crest. Gravity pulls you back down. You swing back through the bottom, the starting point, our 0 line. But you don't stop there. Your momentum carries you backwards, up to a high point behind you. On our graph, that's the downward dip. This lowest point, the valley of the wave, also has a special name, the trough. Finally, you swing forward again, returning to the bottom, the exact same position where you started, ready to begin the next swing. That entire journey, from the bottom, up to the front, back through the middle, up to the back, and back to the middle again, is one complete cycle. It is the full, repeatable unit of the motion. And just like on the swing set, once one cycle is complete, the next one begins immediately, repeating the exact same pattern over and over again. Now, here's a crucial insight. A cycle doesn't have to be measured from the 0 point. We could start our measurement from the very top of the crest. In that case, one full cycle would be the journey from that crest, all the way down to the trough, and all the way back up to the next crest. The shape and the duration are exactly the same. It's a universal, repeating block of motion. This brings us to our next clue on the map, the letter T. In physics, T stands for the period. The period is simply the time it takes to complete one full cycle. So if it took our swing 3 seconds to complete that full back and forth journey, we would say the period of the swing is 3 seconds. The period is the answer to the question, how long does one repetition take? Understanding the period is like having one half of a treasure map. The other half is a concept called frequency. If the period tells us how long a cycle is, frequency tells us how often the cycles occur. Specifically, frequency is the number of complete cycles that happen in 1 second. Think about this relationship, it's beautifully simple. If something has a very long period, it means it happens very slowly. Therefore, its frequency is incredibly low. If something has a very short period, it means it's happening incredibly fast. Therefore, its frequency is very high. We measure frequency in a unit called Hertz, abbreviated as Hz. 1 Hz means exactly 1 cycle per second. Now, let's see how these concepts unlock the secrets of the world around us. Let's talk about sound. When I speak, my vocal cords vibrate, creating cycles of high and low pressure in the air. The frequency of these cycles determines the pitch of my voice. A low, deep bass note from a cello might have a frequency of around 100 Hz. That means 100 complete cycles of pressure change hit your eardrum every single second. A high-pitched sound from a flute could be 2000 Hz. That's 2000 cycles every second. Now, what about light? Light is an electromagnetic wave. And you guessed it, its properties are defined by its cycles. The frequency of a light wave determines its color. Red light has a lower frequency, around 430 trillion cycles per second. Violet light has a much higher frequency, around 750 trillion cycles per second. All the colors of the rainbow are just our brain's way of interpreting the different frequencies of light wave cycles. And what about amplitude? There's one more secret on this map. See how high the crest goes, and how low the trough goes? That distance from the center zero line to the peak is called the amplitude. Amplitude is all about intensity or strength. In a sound wave, a low amplitude is a quiet sound. A high amplitude is a loud sound. In a light wave, a low amplitude is dim light. A high amplitude is bright light. For a wave in the ocean, a small amplitude is a gentle ripple. A huge amplitude is a massive, powerful wave. So, frequency tells you the type of wave it is, like pitch or color, and amplitude tells you its power, like loudness or brightness. Let's look at this image one last time with our new understanding. We see a story unfolding over time. A wave moves away from its equilibrium point. It rises to a crest and falls to a trough. The height of that crest is its amplitude, its strength. One complete, repeatable pattern of this motion is called a cycle. The time it takes to complete this cycle is its period. And the number of these cycles that can happen in a second is its frequency. From the simple swing set in a park to the light from the most distant star, from the music that moves your soul to the electricity that powers your life, everything is dancing to the same fundamental rhythm. It is the heartbeat of our universe. And now, you understand it. You can see it. You can speak its language. Thank you for joining me on this deep dive. I hope you look at the world a little differently now, seeing the beautiful, cycling waves in everything.